Okay, so this is an unstructured AQA exam question worth 9 marks in total. It tells us that a chloride of element Z reacts with water according to the following equation. And in that equation we can see that 1 mole of Z chloride will react with 2 moles of water to produce 1 mole of solid Z oxide and 4 moles of hydrochloric acid. We have information about the mass of the sample that was added to the water, which is 1.304 grams. It tells us the solid ZO2 was removed by filtration and the resulting solution was made up to a 250 centimetre cube volume in a volumetric flask. Now if you look at the products of the reaction, if the Z oxide is removed, then you are basically left with a solution of hydrochloric acid. That is made up to the 250 centimetre cubed in a volumetric flask. From that volumetric flask, a 25 centimetre cube portion of that solution was then titrated against a known concentration of sodium hydroxide. That known concentration is 0.112 moles per decimetre cubed. And in that titration, the average titer was 21.7 centimetres cubed, and that was required to reach the end point. If we then look further into the question, it asks us to use the information to calculate the number of moles of HCl produced and hence the number of moles of ZnCl4 present in the sample. Calculate the relative molecular mass, the MR, of ZCl4 and from your answer deduce the relative atomic mass AR of element Z and hence its identity. In this question we're looking at a straightforward titration involving sodium hydroxide and hydrochloric acid. So the information we need to start looking at is the information that's going to help us to work out, to start with, the number of moles of hydrochloric acid actually produced. So we need to look at our starting point at our concentration of sodium hydroxide and the volume that was used in the titration. Now with the volumes always being in centimetres cubed, you need to first of all convert into decimetres cubed, and to do this you take the value and you divide. So this gives us an added volume of 0.0217 decimetres cubed. This is multiplied by the concentration of the sodium hydroxide in order to be able to calculate the number of moles of sodium hydroxide that was used in the titration. So if we take our concentration here, and if we take our volume of sodium hydroxide here, that produces a final value of 0.00243 moles of sodium hydroxide. Now one key thing to remember about sodium hydroxide and hydrochloric acid reactions, that it is in fact a 1-to-1 ratio. So that means that if we reacted 0.00243 moles of sodium hydroxide, that will also, because of the 1-to-1 ratio, be the number of moles of HCl in the 0.025 decimetre cubed portion that was titrated against the sodium hydroxide. What's quite important in this question to realise is that 0.025 centimetre cubed sample was taken from a total volume. This means that we have to multiply by 10 to give the moles in our 250 centimetre cubed volumetric flask that we originally started with, or 0.25 decimetre cubed volume. This actually means that in our 250 centimetre cubed volumetric flask volume, we actually would have 0.0243 moles of hydrochloric acid. Now, if we again look at the question, we have more information that we can use. We know our Z chloride reacted with the water to produce, in the equation, 4 moles of hydrochloric acid. That shows us a 1:4 ratio. So that means for every 4 moles of hydrochloric acid produced, there would have been only 1 mole of Z chloride used. If we take this ratio into consideration, that means if we have 0.0243 moles of hydrochloric acid, to work out using the 1:4 ratio of how many moles of Z chloride would be, you need to divide by 4. That gives us, based on that ratio, 0.006075 moles of Z chloride. So from the previous part of the calculation, we know how many moles of Z chloride were used based on how many moles of hydrochloric acid was produced, using that 1:4 ratio. Now in the question, it tells us that 1.304 grams of Z chloride was actually added to the water in the first place. So if we look at our equations, and if we look at our mass divided by moles equation, that gives us the ability to work out the molar mass. Basically the number of grams of the substance per mole. When we calculate this, it works out to be 214.7 grams per mole. That is the MR, the molecular mass of our ZCl4. Now in fact, in our ZCl4, we actually know part of that substance. We know there are 4 chlorine atoms in that substance. Now looking on your periodic table, you'll be able to see that 1 chlorine has a mass of 35.5. That's the AR, the atomic mass. So in that total mass for ZnCl4, 4 lots of chlorine need to be taken away. So if we minus from that value 4 chlorines, each with a mass of 35.5, we're going to remove 142. Doing that as a calculation, that leaves us with a value of 72.7. This is the key part. If you now look on the periodic table and look for the element that has this value as its atomic mass, you'll find that we have germanium.